In this video, we're going to review incomplete and codominance. So let's say I have a red flower and a white flower, and I cross those and I end up with a pink flower. That's obviously different than what we've done in the past. And this is called incomplete dominance. And I'm going to write this in a different way in order to show that this is a different type of inheritance. And the way that this works is it's mixing. So I always think of incomplete as mixing or in between. Alright, so in between red and white is pink. And so I would write a red flower as big R, but I'm going to write a white flower not as little r's, but I'm going to put a little apostrophe above them called a prime. So that's be R prime, and then RR prime, which would be the heterozygous genotype, would give me pink. So again, red plus white equals pink. Another example of incomplete would be like long hair, short hair. The heterozygous would be medium hair. It's in between. Alright, now let's say we have a different example where red and white doesn't equal pink, but equals spots. That would be codominance. And again, this is a different type of inheritance from both incomplete and regular. And I think of it as both of them showing up. So it's like co-captains. They both show up. And again, we're going to write this slightly differently. Red is still going to be two big R's. But instead of using primes or little letters, because these are completely different dominant alleles, I'm going to use an entirely different letter. So white would be big W, and then the heterozygous, which is big R, big W, would be spots. So again, red plus white equals red and white spots. They both show up. Now, in some of these cases, we have more than just those two alleles. So for example, you can see here that there are multiple alleles. There's like 3 or 4 different colors. Alright, human blood type puts together multiple alleles and codominance. So we have 3 alleles for blood type. We have A, we have B, and we have O. A and B are going to be codominant, and O is going to be recessive. Now another way that you might see this written is A with an I and then a superscript A, same with B, and then a lowercase I for O to indicate that it is recessive. So you may see it either way. Alright, so let's look at the possible genotypes and phenotypes, because remember, even though I have 3 alleles, I still only end up with 2 in my genotype because I only have 2 parents. So the possible combinations that I could have are 2 A's, an A and an O, 2 B's, a B and an O, an A and a B, or 2 O's. And again, the other way to write that would be like this. Now, because A is dominant over O, both AA and AO give me the phenotype or blood type A. And since, again, B is also dominant over O, BB and BO are also blood type B. Since A and B are codominant, that gives me a different blood type called AB. So remember, that's the codominance right there. And then since O is recessive, the only way to get type O blood is to have 2 O alleles. Alright, so let's see how that works with a Punnett square. If I have a parent that's AO, so they would be blood type A, and another parent that's blood type B, and they're BO, I'm going to set up my Punnett square exactly the same way. Everything works the same way. And I'm going to end up with an AB, a BO, an AO, and an OO. So from these 2 parents, I actually end up with 1, 2, 3, 4 different possible phenotypes. These parents can give me 4 different kids with 4 different blood types. And that's because I have those multiple alleles and I have codominance involved. And that is incomplete, codominance, and blood type.